East Boston is a low-lying neighborhood formed by a collection of 5 islands built entirely on fill. Despite the area's vulnerability, its relative proximity and access to downtown Boston have made it one of the fastest-growing housing markets in the area. As a result, numerous projects have recently been completed on this vulnerable waterfront land, with more on the way. In October 2017, as part of the Climate Ready Boston strategy, the mayor's office released a proposal to deploy a 7-foot-high, $100,000 flood wall across the East Boston Greenway under Sumner Street in order to protect residents, businesses, and infrastructure. While the project represents a step forward in prioritizing climate readiness, we view this project with great skepticism. Not only does the Greenway not address the vulnerability of waterfront development, but adaptation projects such as deflatable flood walls are quick fixes for a much larger problem. Cities are at serious risk from irreversible and significant sea level rise, and to adequately adapt, spatial planning needs a fundamental paradigm shift. So we propose, rather than reduce East Boston's coastline with a barrier at the entrance to the Greenway as currently proposed, we pose a different question. What if we expand the coastline and invite the water in? Our design model is a new form of urbanism and climate change, which we call Bermanism. Unlike other berms, which function only as protective infrastructure, Bermanism is the utilization of a berm not to protect as much land as possible, but as a strategic marker which differentiates areas of upzoning or increased urban intensity with areas of downzoning or return to green space and recreational use. As a physical model and functional object, the berm also serves as an access point and a recreational amenity. Bermanism is derived from 2 other models, scientific climate models on sea level rise and storm surge predictions, and the resilient district concept developed by a team at the Norman B. Leventhal Center for Advanced Urbanism at MIT. By combining climate models with conceptual strategies, we can develop site-specific projects that respond to the needs of the local community while mitigating flood risk over time. Bermanism is more than a physical object. It is a model for representing a shift in urban practice that prioritizes far-sighted, scientifically driven decisions about land use and development, while envisioning a prosperous future for coastal urbanism in the years to come. Rather than a way to preserve the anthropogenic experience, Bermanism acknowledges that what we are willing to give up to the sea can become commensurate with what we gain in return, both in safety and in quality of life. And as a model, it can be replicated in any city affected by sea level rise.